Catholic Academy. We are here again to give you best quality videos on any mathematical topics you wish to find out on. Today's class will be a conclusion of the previous class on indices, and of course, we are going to break it down line by line, so please do watch the end of the class. If you are not able to follow through with the last class we had, the link is attached. Please like, share, and subscribe to our videos. And I will admonish you or anyone that is watching to watch to the end, because there we are going to break down some of the complex indices questions from WAEC, NECO, JAM, and the likes. Thank you. From yesterday's class or the previous class, we were able to explain indices from the first part. We explained the addition, the subtraction, the bracket law, and the zero law. Now, this is an extension of the class. If you are not able to watch the class, the link is attached. So, the first one is a raised to the power minus 1. A raised to the power minus 1. To remove the negative sign, you now have 1 over a. A raised to the power minus 1. Remove the negative sign. Now be 1 over a raised to the power 1. And of course, anything raised to the power 1 is always equals to what? A. So, our answer is 1 over a. So, number 2 is an extension of the previous class, of the previous rule, which is a raised to the power minus m, which is equals to 1 over, to remove the negative sign, 1 over a raised to the power m. Good. Number 3 is a raised to the power m over n. If you look at this m raised to the power n here, the m raised to the power n is a fraction. So, normally what we'll do is that we'll pick the denominator of the fraction, n, root a, which is this, raised to power the numerator, which is m. Just like before in the second rule, where we have a raised to power minus m over n is equals to 1 over n root a all to power m. Just using this rule. The only difference is the negative sign. So how do you remove the negative sign? Do equals to 1 over a equals to 1 over a m over n, as in this rule. So you now have 1 over n root a all to the power of n. So if we have to continue, we'll look at some other examples. From this example 1, this example 1 and this number 1 is the same. So what do? We have 1 over m raised to power 1, which is the same thing as 1 over m, as I explained earlier. Now here, the same rule, 1 over 3 raised to power 3. Remember, there's a negative sign here. And once there's a negative sign here, it will be 1 over 3 raised to power 3, which is 1 over 3 times 3 times 3. That is 3 appearing how many times? 3 times, so which is 1 over 27. That takes us to number 3. Number 3, as in this case, in item 3. So we have 3 root 64 all to the power of what? 2. Meaning, what number will you multiply by itself 3 times that will give you 64? What number will you multiply by itself 3 times that will give you 64? The number is what? 4. So you now have 4 raised to power 2. Of course, 4 raised to power 2 is 4 times 4, which is equals to 16. Good. That takes us to example 4. Example 4 is also an extension of rule number 4. Remember, what do? Remove the negative sign. So we have 1 over a to number 3 over 4. Now, moving on, we now have 1 over 4 root 81 all to the power of 3. Just like we discussed earlier. What number will you multiply by itself 4 times? That will give us 81. And that is 3. So if I do 3 times 3 times 3 times 3, gives me 81. And I bring down this 3. So that is exactly what you do. So 3 raised to power 3, which is 3 times 3 times 3. 3 multiplied by itself 3 times will give us what? 27. Good. So this example 5, decide to combine everything that we have been doing here. This is 32 times 16. We now have 1 over 16 raised to power 1 over 4 times 1 over 2 raised to power 3. Remember, while we are having 1 over is to remove the negative sign here and negative sign here. So we have 32 times 1, 4 root 16 raised to power 1 just like before, times 1 over 8. 1 over 8 because 2 times 2 times 2 is that. So you have 32 times 1 over 2 raised to power 1 times 1 over 8. Good, which is 32 times 1 over 2 times 1 over 8, which is 32 times 1. 1 times 1 is 1, 2 times 8 is 16. 16 here 1, here is 2, so we have 2 times 1 equals to 2. How far? To this point, this is the bonus questions we promised you at the start of the video. If you have gotten to this point, well done. Our advice, you pay careful attention because these are WAEC NECO JAM-based questions that will help our understanding of the concept of indices. So we look at this question. This is 9 raised to the power 2x plus 1 equals to 81x raised to the power minus 2 over 3x. The logical thing to do here will be to what? Cross multiply. If we cross multiply, we have 9 2x plus 1 times 3x equals to 81x minus 2. 9, 3, 81. Our first rule of thumb will be to convert everything to base 3. We ask ourselves, what number are we going to append to 9 so that it gives us a base of 3? Since we have a base of 3 here, we can convert this to a base of 3. We can convert this to a base of 3. So in our case, we have 3 raised to the power 2. Remember, 3 raised to the power 2 is equals to 9. Then we have bracket 2x plus 1 times 3 raised to the power x equals to 3 raised to the power 4. Remember also, 3 raised to the power 4 is 81, which is x minus 2. Good. So we now have 2 times 2x is 4x. 2 times 1 is 2, which is 3 raised to the power x, times 3 raised to the power x equals to 3, 4x minus 8. Now remember the rule of indices. When we have multiplication, what do? We add the power. So we have 3, 4x plus 2 plus x is equals to 3, 4x minus 8. So we collect like times here. 4x plus x is 5x plus 2 equals to 3, 4x minus 8. Since I have a base of 3 and I have a base of 3 here, 3 will cancel out. So you have 5x plus 2 equals to 4x minus 8. 5x minus 4x equals to minus 8 minus 2. 5x minus 4x is x equals to minus 10. This is a simple answer to the question. So when you are doing indices, first and foremost, first rule of thumb, convert everything using any approach or method to base 3. That takes us to question 2. In question 2, we also apply simple multiplication, cross multiplication. So we have 1 times 1 is 1 equals to 81 x minus 2. This times 27 1 minus x. This is 27, we can also convert it to base 3. This is 81, we can also convert it to base 3. 1 we can also convert it to base 3. 1 is 3 raised to the power 0. Why did we use 3? We already agreed that we can convert all of this to base 3. So this one also convert it to base 3. Also recall from the previous class that when we raise a number to the power of 0, the number is equals to 1. So we now have 3 raised to the power 4. 3 raised to the power 4 is 3 multiplying itself 4 times to give us 81. So you have x minus 2 times 3 raised to the power 3, 1 minus x. So we have 3 raised to the power 0. 4 times x is 4x. 4 times 2 is minus 8 times 3 times 1 is 3. 3 times this is minus 3x. The same rule as we did earlier. When we have multiplication, we what? Add. So we have 3 raised to the power 0. 3 is common them. So you have 4x minus 8 plus 3 minus 3x. So you have 3 raised to the power 0. 4x minus 3x is x. Minus 8 plus 3 is minus 5. 3 will cancel 3. So 0 is equals to x minus 5. What we collect like terms, x is equals to 5. The same rule, you can see irrespective of the question you are given, the approach is the same. That takes us to question 3. We do the same thing. We convert any of the numbers. This is base 2, this is base 2, this is base 2. So obviously we have to convert these to base 2. So what do? We cross multiply still. Cross multiply. So we have 2y minus y times 2y minus 1 equals to 2y plus 2 times 2 minus 3y. Good. So what do? We convert this 8 to base 2. So we have 1 minus y times y minus 1 times y plus 2 times 2 raised to power 3. Remember, we got 2 raised to power 3. 2 times 2 times 2 gives us 8. So in simplified form, 2 raised to power 3 bracket 2 minus 3y. So that being said, we simplify still. 1 minus y times 2y minus 1 equals to 2y plus 2 times 2. 3 times 2 is 6. 3 times 3 is minus 9y. Step 2 is to combine them. Remember, this is base 2, base 2. You multiply. This is also base 2. We multiply. So when we have multiplication, we add. When we have multiplication, we add. So we have 2, take one of the base, 2, 1 minus y plus y minus 1 equals to y plus 2 plus 6 minus 9y. So we have 1 minus y will cancel plus y. So 1 minus 1 is also 0. So you now have 2 y minus 9y is minus 8y. 2 plus 6 is plus 8. So in our case, base 2 tend to cancel out. So you have 0 minus 8y plus 8. When we collect like that, we have 8y is equals to 8. Divide both sides by 8. Since 8 is the coefficient of y here, 8 will cancel 8. So y becomes 1. This brings us to the conclusion of the class. If you have come to this end, it means you have not only enhanced your subject, your understanding of the subject, you have also understand the concept of indices, irrespective of the exam you are writing. Remember, this is Success Link Academy, where we do all things mathematics, complex topics, complicated topics. For all WAEC NECO, JAM, or any external exams you're about to write, then this is the right place to be. Remember to like and share and subscribe. If you need any